May 19, 1937. Tokyo, the Imperial Japanese Navy's aviation headquarters, Kasumigaseki District. The room smells of tobacco smoke and green tea. Outside, cherry blossoms have already fallen. Inside, a group of naval officers and civilian engineers are discussing a document that will determine the outcome of a war that hasn't started yet. The document is a design specification. 12 pages. It asks for something that Western aeronautical engineers, if they had seen it, would have called a physical impossibility. Top speed, 500 kilometers per hour. Climb rate, 3,000 meters in 3.5 minutes. Combat range, 2,200 kilometers, farther than from New York to Dallas. Takeoff roll, under 70 meters into a 12-knot headwind, from the deck of a carrier, and full aerobatic maneuverability at all altitudes. One of the engineers in that room, a quiet, precise man of 32, named Jiro Horikoshi, chief designer at Mitsubishi's Nagoya facility, reads the specifications and knows immediately what they will require of him. Not brilliance, not genius. Those he has in abundance. They will require him to make a choice that brilliant engineers almost never survive making correctly. He will have to build an aircraft that is perfect, and perfection, in engineering as in war, always has a price. That price would not be paid by Jiro Horikoshi. It would be paid by thousands of young men who would climb into his creation and never come back. It would be paid by Japan in a currency of dead pilots that no factory could replace. It would be paid at Midway, at Guadalcanal, at the Philippine Sea, until finally, by the autumn of 1944, Japan would find itself with thousands of his aircraft and no trained men to fly them, and would arrive at the most desperate, most revealing decision of the entire Pacific War. This is not a story about a fighter plane. This is a story about a decision made in a conference room that determined the outcome of a world war. It is a story about how the most advanced carrier-based fighter aircraft ever built, in 1940, became, by 1944, the instrument of its own nation's destruction. It is a story about how Japan's greatest military achievement was also Japan's greatest strategic trap, and it begins with a weight budget. In the spring of 1937, Jiro Horikoshi had already designed 2 carrier fighters for the Imperial Japanese Navy, the A5M Type 96, which had performed adequately over China, and he understood the Navy's culture better than most. The IJN did not ask for adequate. The IJN did not ask for good enough. The IJN asked for perfection, and it asked for it on a schedule, and it asked with the implication that failure to deliver was not merely professional embarrassment, but national dishonor. So when he received the May 1937 specification, officially designated Jukugo Ichi Shiki Kanjo Sentoki Keikaku Yokusho, the 12th year type carrier fighter development specification, Horikoshi did what a brilliant engineer does. He did not say it was impossible. He did not push back on the requirements. He went to his drawing board and he did the mathematics. The mathematics were brutal. Any aircraft meeting those range and speed figures with the engines available in 1937, Japan would weigh, at minimum, 1,800 kilograms empty. But at 1,800 kilograms, achieving a climb rate of 3,000 meters in 3.5 minutes was aerodynamically implausible. The power-to-weight ratio simply wasn't there. And to carry enough fuel for 2,200 kilometers of range while maintaining that weight target required structural compromises that no Western aviation authority would have permitted. Horikoshi understood this. His engineering team understood this. The solution they arrived at was elegant in its logic and catastrophic in its consequences. Strip everything. In the Nagoya facility in the summer and fall of 1937, Horikoshi and his team maintained what became a legendary document inside Mitsubishi, a gram-by-gram weight budget for every component of the prototype, not kilogram, gram. The specification had essentially assigned a weight ceiling for the entire aircraft, and Horikoshi's team worked backward from that ceiling with the precision of surgeons. The structural spars were designed from a new aluminum alloy called Extra Super Duralumin, developed specifically for this project, that was 30% stronger than standard aviation aluminum at the same weight. This allowed thinner wing skins, narrower frames, lighter longerons throughout the fuselage. The weight savings were genuine and significant, but they were not enough. So the team removed the pilot armor, approximately 30 kilos of steel plate behind the pilot's seat that, in German and British and American fighters, was considered standard equipment, the minimum protection against bullets entering from behind. Gone. The engineers noted it in the weight budget. They did not debate it at length. The specification required what it required. They removed the self-sealing fuel tank liners. These were rubber bladders inside the fuel tanks that would expand and seal bullet holes, preventing the catastrophic fuel fires that killed so many pilots. The lining added weight and reduced fuel capacity. Both were unacceptable. Gone. They designed the wing structure to the thinnest margins. The Zero's wings were extraordinarily thin, a design choice that maximized aerodynamic efficiency at the cost of structural redundancy. The aircraft's high-speed dive limit would be set at around 410 knots indicated airspeed, beyond which the controls became dangerously heavy and the airframe risked structural failure. That limit existed because the wings couldn't be made any stronger without adding weight that would compromise the climb rate. The engineers knew this. They wrote it into the test pilot notes. By the spring of 1938, the prototype took shape. When test pilot Katsuzo Shima climbed into the cockpit of the A6M1 for its first flight on April 1, 1939, he found an aircraft of remarkable delicacy, light on the controls in a way that immediately communicated extraordinary maneuverability, responsive to every input, almost telepathic in its reactions to the pilot's intentions. He found exactly what Horikoshi had designed, a machine optimized for one thing, killing at the moment of engagement. What Horikoshi had not designed, could not have designed under the specifications he'd been given, was an aircraft that would keep its pilot alive after the engagement was over. The distinction would take 3 years to become clear, and then it would become very clear indeed. The Navy accepted the aircraft as the A6M2 Type 00 carrier fighter, Type 0, in the Western calendar year, giving it the name that history would remember. It exceeded the specifications. Top speed, 533 kilometers per hour, climbed to 3,000 meters, 3 minutes, 35 seconds. Range with drop tanks, 3,350 kilometers. Maneuverability, beyond anything the IJN's test pilots had imagined. The engineers who had signed off on removing the armor plate declared victory. They were correct. The Zero was everything they had promised. They were also building a coffin, a beautiful, efficient, perfectly balanced coffin. September 13th, 1940, the sky above Chungking, China, is thick with summer haze. The Chinese Air Force has scrambled to intercept what they believe are Japanese bombers. What they find instead is something else entirely. 13 Zeros, led by Lieutenant Saburo Shindo, meet the Chinese formation, 27 fighters, a mix of Soviet-supplied I-15s and I-16s, flown by experienced pilots who have been fighting the Japanese for years. The Chinese pilots are not novices. They have shot down Japanese aircraft before. They have no reason to expect what happens next. In 30 minutes, 27 Chinese fighters are destroyed. Not damaged, not driven off, destroyed. Japanese losses, 0. The combat reports that flowed back to Tokyo that evening were not believed at first. A 27-0 exchange ratio against modern fighters seemed impossible. The Navy sent investigators to confirm. The investigators confirmed the Zero had performed exactly as advertised. In Claire Chennault's American Volunteer Group intelligence files, a warning went out. Chennault, who would later command the Flying Tigers, compiled what he knew about this new Japanese fighter from Chinese pilot reports and sent a detailed brief to the U.S. Army Air Corps and the U.S. Navy. The Zero was faster, more maneuverable, and longer range than any American carrier fighter then in service. American pilots needed to know this. Washington received the reports. Washington filed them. This failure to act on Chennault's warning is one of the most studied intelligence failures in military history. But the more important failure was happening in Tokyo, and it was a failure of a different, more dangerous kind. The Zero's success over Chungking did not prompt Japanese naval planners to immediately develop a successor aircraft. It prompted them to build their entire operational doctrine around the Zero's performance. This is the mechanism of the trap, and it is worth understanding precisely. Commander Minoru Genda was the most brilliant air warfare theorist in the Imperial Japanese Navy, a graduate of the Naval Academy, a veteran pilot, a man who thought about carrier aviation with the systematic clarity of a chess grandmaster. In 1940 and 1941, Genda was designing the operational architecture of Japan's opening offensives in the Pacific, and the Zero was not merely one component of his plans. The Zero was the load-bearing structure. Consider what the Zero's 200-kilometer operational range made possible. Without it, the Pearl Harbor attack was geometrically impossible. The planned strike package required carrier aircraft to fly approximately 350 miles from the launch point to Hawaii, execute a full combat engagement, and return. No other carrier fighter in the world in 1941 had that range. The attack worked precisely because the Zero could do what other fighters couldn't. Consider what the Zero's maneuverability enabled in the Philippines, in Malaya, in the Dutch East Indies. Japanese Zero pilots could outfly anything they met. They could protect their own bombers and destroy enemy fighters at will. The conquest of Southeast Asia proceeded on the Zero's performance envelope as surely as it proceeded on Japanese ground forces. And this is where the trap closes. When an operational system succeeds brilliantly, the institutions built around it become deeply invested in its continuation. The IJN had built its training pipeline, its tactical doctrine, its strategic planning, its carrier deck organization, all of it around what the Zero could do. Success made that investment seem wise. The question no one was asking, loudly enough to be heard, was, what happens when the Zero can no longer do it? Admiral Isoroku Yamamoto, commander of the Combined Fleet and the most strategically sophisticated mind in Japanese naval command, was asking it privately. His post-war diaries and communications, examined by historians after the war, show a man who admired the Zero's capabilities while harboring growing anxiety about the training pipeline. Japan in 1941 graduated approximately 100 carrier-qualified pilots per year. The training pipeline was demanding. Carrier qualification required roughly 700 flight hours, years of progressive instruction, a washout rate that meant only exceptional candidates reached fleet squadrons. Yamamoto understood arithmetic. The Zero's pilot could not be mass-produced, and war, as Yamamoto had studied at Harvard and observed as naval attaché in Washington, was ultimately a mathematics problem. Production, replacement, attrition. Japan's solution to the mathematics problem was to have pilots who were so good that the mathematics would never apply to them. This was the thinking of a civilization that had never lost a major war. By late 1941, 3,500 carrier-trained aviators represented Japan's total irreplaceable investment in naval air power. They were the best-trained naval pilots on Earth. They were the product of a decade of intensive instruction. They were the Zero's pilots, and Japan was about to send them to war. The Battle of Coral Sea, May 1942. The first major carrier engagement in history, a battle in which the opposing fleets never saw each other, fought entirely by aircraft. From an operational standpoint, it was roughly a draw. Japan sank the carrier Lexington and damaged Yorktown. The US sank the light carrier Shoho and damaged the fleet carrier Shokaku severely enough to remove her from the next engagement. But embedded in the damage reports and casualty lists was a figure that Japanese naval planners would not fully reckon with until it was too late. Japanese aircrew losses at Coral Sea were significant and included veterans who had been flying since China. These men, with their hundreds of combat hours, Their deeply internalized feel for the Zero's unique handling characteristics, their tactical judgment built over years, were gone. They could not be replaced in 6 months. They could not be replaced in a year. Training a pilot to their standard required 2 to 3 years under the pre-war curriculum. Coral Sea was the aperture through which Japan's most critical vulnerability became visible. Midway slammed it wide open. June 4th, 1942. The mathematics of irreversibility. 4 Japanese fleet carriers, Akagi, Kaga, Soryu, Hiryu, and their embarked air groups represented the concentrated core of Japanese carrier aviation. The pilots aboard those ships were the veterans of Pearl Harbor, of the Indian Ocean Raid, of Coral Sea. They were, by any measure, among the finest combat aviators in the world. Jonathan Parshall and Anthony Tully, in their definitive study Shattered Sword, the most rigorous accounting of Midway ever published, arrived at the specific figure that defines what the battle actually meant to Japan. 409 trained aviators lost in the Midway engagement, accounting for killed and wounded in the sinking of 3 carriers and the loss of the Hiryu's air group. 409 men, with average flight hours, before the battle degraded the average, of between 500 and 800 hours each. To understand what this number means, you need to understand what it takes to build a Japanese naval aviator in 1941. A candidate entered flight training and spent months on primary instruction. He then progressed to advanced training. He spent additional months learning carrier operations, the arrested landing, the catapult launch, the deck handling, the formation flying at sea. He drilled and was evaluated and drilled again. By the time a pilot achieved carrier qualification under the pre-war standard, he had accumulated roughly 700 flight hours and invested 2 to 3 years of his life. The washout rate throughout this process was severe. The IJN accepted that most candidates would not make it to fleet assignment. Japan's pre-war training pipeline graduated approximately 100 carrier-qualified pilots per year. At that rate, replacing 409 lost aviators would require more than 4 years of training output. Japan did not have 4 years. The Pacific War, from Pearl Harbor to Midway, had consumed 6 months. In those 6 months, Japan had expended a generation of investment, and the war had barely begun. Admiral Chuichi Nagumo, who commanded the carrier striking force at Midway and survived the disaster, was captured by the Americans in 1944 on Saipan and chose death over capture. But his statements to staff officers before the end, preserved in post-war interviews with survivors, were unambiguous. Midway's pilot losses, he said, were the wound that could never heal. The ships could be rebuilt. Steel and aluminum were materials. The men who knew how to fight from carriers, how to read the sea and the sky together, how to find a target at the limit of fuel range, how to coordinate torpedo and dive bomber attacks into a synchronized strike. Those men took years to make and could not be summoned from nowhere. He was right, and the evidence was already visible in the training pipeline by the autumn of 1942. Guadalcanal, August 1942 through February 1943. 6 months of attrition warfare over the jungle airstrip the Marines had seized and the Japanese were trying to take back. The Zero was still formidable. Japanese pilots still won individual engagements, but the aggregate was inexorable. American production of trained pilots was accelerating. American losses were being replaced. Japanese losses were being replaced with men who had fewer hours, less experience, less time in the Zero's particular and demanding cockpit. The Zero, recall, had been optimized for peak performance, which meant it was an expert's machine. It responded brilliantly to a skilled pilot and killed an unskilled one. The control forces, the handling characteristics, the tendency to snap roll at low speed, the structural limits on high-speed dives, all of these demanded the pilot that Japan was running out of. By early 1943, Japanese naval aviators arriving at Guadalcanal with 200 flight hours were meeting American pilots who had trained on the Wildcat, had been coached by veterans of earlier engagements, and were flying with the situational awareness advantages that American radar and radio networks provided. The kill ratios were converging, not because the Zero had changed, because the pilots flying it had, and the Zero could not protect them. It had never been designed to protect anyone. The unarmored cockpit, the fuel tanks without self-sealing liners, these were irrelevant when experienced pilots were avoiding the hits. Against pilots with 200 hours, against the inevitable friction and error of combat, they were death sentences. IJN medical officers in the Solomons began documenting a phenomenon they labeled zero fighter neurasthenia, a combination of exhaustion, demoralization, and what we would today call combat stress disorder, affecting pilots who had survived the Guadalcanal campaign long enough to understand what was happening to their peers. The mathematics were becoming visible even to those living inside them. Every mission, the pilots flying with them were a little less experienced. Every loss was a little harder to absorb. And the Zero, their miraculous Zero, the machine that had made them gods above China, offered them no protection when the mathematics finally caught up. By February 1943, when the Japanese evacuation of Guadalcanal completed, the IJN had lost approximately 880 aircraft in the Solomons campaign. More critically, it had lost the pilots, experienced men, irreplaceable by any standard the training system could meet. The crack that Coral Sea had opened, Midway had widened, and Guadalcanal had made into a chasm. And somewhere in Nagoya, Jiro Horikoshi was already working on what was supposed to come next. In the autumn of 1942, the Imperial Japanese Navy's Aviation Bureau issued a requirement for a Zero successor. This was not panic, it was recognition, long delayed, that the Zero had been designed around 1937 engine technology and that 1942 demanded something fundamentally different. The new aircraft needed armor, it needed self-sealing tanks, it needed a more powerful engine, it needed to defeat the new American fighters that were beginning to appear, the Corsair, the Hellcat, the improved Wildcat. The Navy turned to the same man who had built the Zero. Jiro Horikoshi received the A7M Repu specification in 1942 and began what would become one of the most agonizing engineering efforts of his life. His private diaries, published posthumously and available in English translation, chronicle a man straining against every constraint simultaneously, material shortages as Japan's strategic resources dwindled, engine failures from the Mitsubishi Ha-43 power plant that should have given the aircraft its performance advantage, design committee disagreements that reflected the broader dysfunction of a military bureaucracy under war pressure, and the increasingly obvious fact that Japan's manufacturing capacity was not equipped to produce the Repu in useful numbers, even if the design problems were solved. The Ha-43 engine was the central disaster. It was a powerful engine, theoretically superior to anything powering the Zero, but in 1942 and 1943 and 1944, it refused to work reliably. Bearings failed. Cooling was inadequate. The engine that the Repu needed to exist kept failing on the test stand and in prototype airframes. Horikoshi's team worked around the problem, substituted components, revised the design, and the months passed. René Franchillon's comprehensive study of Japanese aircraft details the Repu's development history with unsparing specificity. The first prototype flew in May 1944, 2 years after the specification had been issued. It was promising. The performance figures were competitive, but promising prototypes in 1944 were not aircraft in fleet squadrons. By the time the Repu was ready, Japan's ability to manufacture it in meaningful numbers had been severely compromised by American bombing of industrial facilities, raw material shortages from submarine interdiction of shipping lanes, and the simple fact that the production engineering required to mass-produce a new airframe takes time that Japan no longer had. 9. While Horikoshi's team struggled with the Repu, something was happening in the United States that Japan's Aviation Bureau was watching with growing dread. In the summer of 1942, a Zero had come down more or less intact on the island of Akutan in Alaska. A pilot, disoriented, had crash-landed in a bog and the aircraft had survived with repairable damage. American engineers recovered it, repaired it, and flew it extensively against every American fighter then in service. They learned exactly what the Zero could do. They learned its dive limitations. They learned its roll rate at high speed. They learned where it was fast, where it was slow, and where, if you could get it, it was completely vulnerable. They gave the data to Grumman. Leroy Grumman's engineering team at Bethpage, Long Island, was already developing a new carrier fighter when the Akutan Zero data arrived. The F-6F Hellcat was not designed exclusively to kill the Zero. It was designed to be a better carrier fighter than the F-4F Wildcat, which was adequate but not dominant. But with the Zero's performance envelope mapped precisely, the Hellcat's design was refined to ensure it could defeat the Zero at every altitude and every dive speed where combat was likely to occur. The Hellcat was heavier than the Zero, considerably heavier. It weighed nearly twice as much empty. It was not as maneuverable in a slow-speed turning fight, and none of that mattered, because the Hellcat was designed for a different kind of war than the Zero, a war in which the aircraft might take battle damage and bring its pilot home. A war in which an inexperienced pilot could get into the cockpit and survive long enough to become experienced. The Hellcat had armor behind the pilot's seat. It had self-sealing fuel tanks. It had a robust, redundant structure that could absorb punishment. It had a Pratt & Whitney R2800 engine, producing 2,000 horsepower, power that gave it a speed and climb advantage over the late-war Zero that the Zero's pilots, now so often undertrained, had no effective answer for. The Hellcat entered fleet service in August 1943. The contrast in manufacturing scale was not even competition. The Grumman factory at Bethpage was producing Hellcats at a rate that Mitsubishi's Zero production could not approach. American industrial capacity had been organized for mass production from the beginning. Standardized components, trained workers, logistics chains that could sustain continuous output. By the end of the war, Grumman had delivered more than 12,000 Hellcats. Mitsubishi had delivered approximately 10,939 Zeros across the entire war, but the comparison is misleading because Japan's industrial capacity was degrading as America's was growing. The Hellcat's kill ratio against the Zero from its introduction through the end of the war stood at approximately 19:1. Some historians dispute the specific figure. None dispute the direction. The U.S. Strategic Bombing Survey Report, number 62, Japanese Air Power, compiled from captured Japanese documents and officer interviews in 1946, contains the testimony of IJN officers who watched this reversal happen. The language in these testimonials is measured, professional, and devastating. Japanese officers who had designed the carrier aviation system that swept across the Pacific in 1941 and 1942 describe, in the clipped vocabulary of military bureaucrats, the systematic collapse of their pilot inventory. In 1941, IJN carrier pilots averaged 700 flight hours before combat assignment. By late 1943, the average had fallen to under 300. By 1944, pilots were being sent to fleet squadrons. With 200 hours, by the end of 1944, some carrier pilots had fewer than 100 hours of total flight time, and they were flying a Zero, the aircraft that Jiro Horikoshi had built to reward mastery and punish inexperience. The mathematics of this situation resolved itself with the inevitability of a proof. June 19 to 20, 1944, the Philippine Sea. The engagement that American pilots nicknamed the Marianas Turkey Shoot, Japanese carrier aviation committed its remaining strength, 9 carriers, approximately 430 aircraft, to stop the American landings in the Marianas. The American Fast Carrier Task Force waited with Hellcats, directed by radar, controlled by experienced fighter directors, flown by pilots with hundreds of hours and 12 months of combat-evolved tactics. In 2 days, Japan lost approximately 476 aircraft and 3 carriers. American losses, 130 aircraft, no carriers. The pilots flying those Japanese aircraft were not cowards, they were not inadequately motivated. Many of them flew with extraordinary courage into situations that their training had not prepared them to survive. They were flying a Zero that was now outclassed by the aircraft meeting them. They were flying with fewer hours than the men who had flown from Pearl Harbor had accumulated in their first year of training. And they were flying against an American system of radar, radio, training logistics, replacement that could absorb any attrition they could inflict and return to the fight at full strength. The Philippine Sea was not a battle, it was an audit. It audited the consequences of every decision made since May 1937, and the result was a number. Japan had run out of the kind of pilot who could fly the Zero the way the Zero needed to be flown. In Tokyo, the Naval Aviation Bureau confronted a situation that had no good solution. They had thousands of Zeros in inventory, in various stages of airworthiness, distributed across the Pacific. The aircraft, in conventional combat against late-war American fighters, was no longer effective. The pilots available to fly them, with their compressed training and limited hours, could not change this equation through skill or determination. What Japan had was an aircraft optimized for offensive lethality in the hands of an expert, now operated by non-experts, in a defensive situation. The equation that Jiro Horikoshi's weight budget had established in 1937, performance at the cost of survivability, had always depended on the pilots being good enough that survivability didn't matter. Those pilots were gone. The solution that emerged in October 1944 has been written about primarily as a product of Japanese military culture, of Bushido, of sacrifice of a warrior tradition that valued death over surrender. This cultural dimension was real, and should not be dismissed. But it was not sufficient as an explanation, and it obscures the industrial and operational logic that made the kamikaze program not merely possible, but from a certain bleak analytical perspective, rational. Japan had aircraft that couldn't effectively fight, and pilots who couldn't effectively fly them. The conventional combination, aircraft and pilot as a weapon system engaging in traditional air combat, was producing losses without results. But an aircraft flying in a straight line toward a stationary target didn't require aerobatic skill, tactical judgment, or combat experience. It required only enough competence to reach the target area. The Zero's 200-kilometer range and its remaining speed were still useful for this purpose. The Zero survivability design, the unarmored cockpit, the unprotected fuel tanks, was now irrelevant, because survival was not part of the mission. The kamikaze program was not born from fanaticism alone. It was born from a supply chain problem. Japan had the wrong aircraft and the wrong pilots for conventional combat. The kamikaze concept converted both into an asset for one-way missions. From October 1944 through August 1945, kamikaze attacks damaged or sank hundreds of Allied vessels and killed approximately 4,900 American sailors, the highest American naval casualty toll from any single cause in the Pacific War. The attacks were tactically effective in a way that conventional Japanese air combat by 1944 was not. They could not change the trajectory of the war. Japan's industrial capacity was collapsing under bombing and blockade. The pilot pipeline had been exhausted. The aircraft production lines were being disrupted by the same bombing campaign destroying Japanese cities. The Philippines had been lost. The Marianas were in American hands, and B-29s were flying from them to burn Japan's cities. The kamikaze was Japan's admission that the conventional air war had been lost. It was the final transaction of a bankruptcy that had been accumulating since June 1942. Jiro Horikoshi spent the final year of the war as a man watching his creation be used in ways he could not have imagined in 1937. He was still at Mitsubishi, still working on the Repu that never came, aware that the aircraft his team had stripped to bare essentials for maximum performance was now being used as a weapon in which the pilot was the warhead. He left no public statement about the kamikaze program during the war. What he left was his work, the engineering notebooks, the design records, the weight budgets with their notations of what was removed and why. After the war, he spent years writing Eagles of Mitsubishi, the story of the Zero fighter, published in Japanese in 1970 and translated into English in 1981, is a meticulous technical memoir. It is also, between its precise engineering descriptions and its careful recountings of design meetings, a document of a man who spent his life understanding exactly what he had built and exactly what it had cost. He writes about the design specifications' constraints without self-exculpation. The Navy required what it required. He built what could be built to those requirements. The trade-offs were rational, given the information available in 1937. No armor plate saved weight that was translated directly into range that made Pearl Harbor possible. No self-sealing tank liner contributed grams that became meters of altitude and seconds of climb rate that made the Zero lethal over China. He knew the trade-offs when he made them. What he could not have known, what no one in that Tokyo conference room in May 1937 could have known, was the full mechanism of the trap. The trap required not just the Zero's design decisions, but the success that followed. If the Zero had been mediocre, Japan would have developed a successor. If the Zero had lost pilots at a rate that was visible in 1940 or 1941, Japan would have developed a successor. It was precisely because the Zero was so extraordinarily effective in the hands of its initial pilots that the structural dependency became total before the structural fragility became apparent. The Zero succeeded brilliantly, and that success prevented Japan from asking the question that might have saved its naval aviation: what happens when the pilots are gone? The final statistics speak in the language that Jiro Horikoshi understood, the language of numbers. Total Zeros produced, approximately 10,939. Total American Hellcats produced, approximately 12,275, but production numbers alone don't capture the asymmetry. By the end of the war, the US was graduating approximately 100,000 pilots per year. Japan's pilot training program, which had produced perhaps 100 carrier-qualified pilots annually in its pre-war peak, had been forced to compress its curriculum so severely that the men coming out the other end were not comparable to the men who had gone in. The U.S. Strategic Bombing Survey interviewers, working through Japanese naval records and officer testimony in 1945 and 1946, documented the specific moments at which Japanese commanders recognized the irreversibility of their position. These are not dramatic admissions, they are the flat, matter-of-fact acknowledgments of professionals who understood what the numbers meant. One senior IJN aviation officer, interviewed for the USSBS report, and quoted in its findings, stated that after Midway, the loss of experienced pilots could not be overcome. New pilots could be trained, he said, but the time required was not available. The Zero's demands for pilot skill were known. The training system's output was known. The mathematics produced only one answer, and it was not a favorable one. The post-war period brought former enemies into the same rooms for the first time. Japanese pilots who survived the war, American pilots who had fought them, engineers from both sides. They met at reunions and symposia through the 1950s and 1960s and examined together what had happened. Saburo Sakai, Japan's greatest surviving ace, credited with 64 aerial victories, one of the handful of veteran Zero pilots who lived through the entire war, spent decades after it examining the Zero's history with an unsentimental precision that his memoir Samurai captures with remarkable honesty. Sakai acknowledged that the Zero had been unmatched in 1941. He also acknowledged that the loss of experienced pilots had destroyed Japanese carrier aviation as a coherent force. He had felt it happening around him, the pilots flying his wing getting younger, less experienced, less able to handle what combat demanded. He had survived partly because he was extraordinary, partly because he had survived long enough to learn everything the war could teach, and partly because of the statistical fortune that attends any long career in combat aviation. Most of his contemporaries had not survived. The Zero itself survives today in only a handful of airworthy examples worldwide. a testament to both its scarcity and to the remarkable preservation efforts that have kept these artifacts of 1937's engineering genius in flyable condition. At the National Air and Space Museum's Udvar-Hazy Center in Chantilly, Virginia, a Zero hangs from the ceiling near examples of the aircraft that defeated it. The museum's placard describes its specifications accurately. What it cannot fully convey is the weight of what those specifications cost. The Pearl Harbor Aviation Museum in Hawaii displays a Zero in the context of the attack it made possible, the aircraft that struck the first blow in a war it could not ultimately sustain. These are not trophies, they are evidence. They are the physical remnants of a decision made in a Tokyo conference room in 1937, when a group of naval officers and a quiet, precise engineer sat around a table and agreed that performance was worth more than survivability, that the pilots were good enough, that survivability didn't matter, and that Japan's advantage in human skill would outlast any American advantage in industrial capacity. They were wrong about the last part, and the first two parts were precisely what made the last part wrong. America's response to the Zero was not to build a better Zero, it was to build an entire system of production, of training, of logistics, of tactical doctrine, of industrial capacity that could absorb any losses the Zero could inflict and replace them, then absorb the next losses and replace them, then absorb again. The Hellcat was not a more perfect aircraft than the Zero. It was a different argument about what mattered in a war. The argument was that enough aircraft, made fast enough, flown by pilots trained well enough, and replaced fast enough, would defeat any number of perfect aircraft flown by irreplaceable pilots. The argument was correct. This is the story that military historians and business school professors and war college strategists return to, decades later, because it is not a story about a war. It is a story about two fundamentally different theories of how human systems operate under pressure. The Japanese theory that peak performance is irreplaceable, and the American theory that adequate performance, scaled and sustained, defeats peak performance in any contest of sufficient duration. Jiro Horikoshi lived until 1982. He died at 78, having spent 4 decades after the war writing and speaking and being asked, again and again, about the Zero. He answered with engineering precision and a characteristic refusal to either congratulate himself or engage in self-condemnation. He had built what he had been asked to build. He had built it better than anyone thought possible. He had built it so well that it had helped reshape the Pacific. He could not have stopped what followed. The design decisions were rational. The specifications were what they were. The pilots who flew his aircraft were brave and skilled. The circumstances that led from his drawing board to the Marianas turkey shoot and the kamikaze attacks, those circumstances were larger than any individual, larger than any aircraft, larger than any conference room in Tokyo. But he could not forget it either. His diaries and his memoir, and the testimony of those who knew him, suggest a man who spent his remaining years in a kind of permanent examination of a decision he had made correctly and that had ended in catastrophe. There is a word in Japanese, monano aware, that describes the bittersweet awareness of transience, the recognition that the most beautiful things are beautiful, in part because they are temporary, the cherry blossoms that fall, the moment of perfect achievement before the arc of decline. Jiro Horikoshi built the most capable carrier fighter in the world in 1940. It was extraordinary. It was irreproducible. It was fragile in the specific way that perfection is always fragile, completely dependent on conditions that cannot last. He understood the trade-offs when he made them. He spent the rest of his life understanding the ones he hadn't seen. Remember that design specification from May 1937, those 12 pages that asked for the impossible. The engineers who wrote it believed that demanding perfection would produce it. They were right. Jiro Horikoshi delivered everything they asked for, and he delivered it on time. By May 1945, the empire that had written those specifications was in ruins. Its cities were burning. Its carrier fleet was at the bottom of the Pacific. Its best pilots were gone, replaced by boys in cockpits with less than 100 hours of flight time. The specification had been met. The war had been lost. The Zero flew perfectly to the end. That was always the problem.